This is going to be a local study which was carried out quite long ago, but I'm trying to present it. All in all, it's going to be difficult. I'm going to bomb you with several graphs. I'm trying to explain them very shortly. I hope I will succeed. Afterwards, we can discuss anything. Uh-oh. Yeah, this. It's distorted and okay. And I don't know why.
Okay, but the rest looks okay.
Yes, it's
so
okay.
Maybe it's
all right. That's just the first side, okay.
Sorry?
So fire has been used by people in the mountain area, and it can easily lead to wildfires, devastating forest. What is important here, this forest is the water tower, serving people and animals with qualitative and quantitative water. That's why we would like to define optimized fire management strategy. The study area, stakeholders, governmental forestation, governmental Mount Canyon National Park, localities living all around it, and of course, what is our interest in mainly is the forest here, but the moorland is very specific and unique. Ecosystem is also affected. The data used, I had a lot of information, a lot of GIS-based data from Canyon partners, remote sensing, open source available data, and quantitative indices done by Kevin, who is a PhD student here. It was done by doing a lot of workshops and surveys there with localities involving all stakeholders. This is actually my main SDG is number 6, clean water, but all of them are based on that one, so they are intertwining. This is one of the photos of the workshops. That's just a map created by me, a simple map, and they used it, of course. The results, the first results of the fire, or the most detected fire occurrences is the seasonality. W seasonality January-March is much higher than, it's not visible, but it is white, than April to December. And the dual seasonality is remarkable. We have to apply spatial point pattern analysis. First of all, no complex spatial randomness because the lines are deviating, and the V-variance ratio resulted for 5-kilometer rasters clustering pattern for the fire occurrences. The same valid for the minimum mean distance, which is from 6 to 9 meters. Deviating lines means also clustering fire patterns. It's a very, very short distances, the 8 meter. And the next slide, if it comes, shows us also the same clustering pattern, but for 200 and 300 meters, where the line starts going parallel each other, there it finishes. That's why I applied classification, and the classification, all fire occurrences were binned into ignition points based on fire detected on the first day, and only on the first day, and afterwards they were mixed with attributes of the satellite data, and they were put into ignition sites. And it's resulted into less autocorrelation, no positive, no negative values, very smooth line here in the middle, which means that the fire occurrences and the ignition points became independent. That's what I wanted to do, which means we have the ignition sources and not there are so many fires aggregating on one day. This is also a comparative analysis of the fire occurrences and the ignition sources. There is no differences between the densities. So there is differences between the densities, and here is pronounced that they are all in the middle of the agricultural field. And this is another, the burnt area analysis. It also pronounced very well the dual seasonality. The numbers indicates how much burnt area per hectare was burnt. And this is actually, these are selected years, where the fire the burnt area is really relevant in each year, and just to show you how much burnt area was per year. It's very changing. It's like fluctuation. You can't really predict it, what's going to happen next year. That was for April, December, and this is for January, March, for the main season. Here you can see that it shifts slowly to the moorland and leaves the forest. It also keeps actually the forest at a defined altitude. But this is a lot more here. And all in all, the result is that, it's not visible here, yeah, okay, that we have more on the moorland, but less frequent, and more frequent and less in the forest, within the forestations, but more frequent. This is, I drew all the roads which was possible according to the satellite data. I buffered them and I tried to relate to the ignition sources. It's a very nice coverage for April and December. Regarding January, March, it's more or less the same. This area is shaded because it couldn't be, the roads here couldn't be drawn due to satellite cloudiness. But it also shows that the roads and the accessibility is very important factor here. This is the fire hazard map, which was the aim of the whole study, based on 9 socioeconomic factors. This is the honey collecting related to fire hazard, and it was produced 9 times, and the new shape files. Was it possible to do it? There were Kenyan partners, of course. There was Kevin, who helped a lot, who did everything which was possible regarding virtual social economic surveys, an independent researcher, Italian, BOKU professor, and the available technical and institutional framework of BOKU. And yes, how did we get here? It's all about intertwining. I put BOKU in the middle, and it also shows that actually all the SDGs are very nicely and sustainably performed by BOKU as well, regarding my study, and which was the SDG 6. Thank you very much. I think it was a bit dense, but I am open for questions.